and I'll let you know when it's live. Okay, you are live.
Thank you. All right, Mora, welcome everyone. I would like to welcome you on behalf of the New Zealand Antarctic Society, as the president of that society, to this exciting current and topical webinar about the progress so far on the Scott Base redevelopment. I know that we're all really looking forward to this. We are really fortunate too in that the Antarctic Society has partnered with the Antarctica New Zealand, and we have two highly respected speakers, one being Simon Shelton and the other one being Hugh Broughton. I'd like to also encourage you to think about, I have to do the marketing spiel here. I'd like to encourage you to think about joining the Antarctic Society with the latest double issue, for instance, which comes with a very large map. I'll hold both of these up in a moment. And it costs a mere $75 per person to join for an annual subscription. And as you can see, we have already run and been part of, I don't know if you do know this, 2 webinars already this year, and this being the 3rd. And something that probably the Antarctic Society hadn't even considered until about a month ago was to actually have its own YouTube channel. So this is all new stuff for us. And so I will just hand this up a moment. Here we are. This is what the double issue looks like on the front. And here, I can't hold the whole thing up, but effectively this whopping great map of the Antarctic, which hasn't been published by the LINZ or Land Information New Zealand for several decades, probably 2 decades. So this is a brand new thing that comes free with the particular double issue. But now what I would like to do, without any further ado, is hand over to Tamsin Falconer, who is the chair of the Antarctic Society Scott Base Subcommittee, and also welcome Samantha Chapman from Antarctica New Zealand, and also welcome both Hugh and also Simon, and to say enjoy.
Great. Thanks very much, Linda, and kia ora koutou. It's very nice to be talking with you all. I'm not sure how many there are, but I know there is a queue of people lining up just before we started. I've been a member of the Antarctic Society in New Zealand since 2000, soon after I returned from my first trip to Antarctica, and I did a little project supervised by Dr. Linda Kessel looking at the TAE hut. And so that was my first exposure to kind of the development of Scott Base over time. So it's really a great pleasure to be part of this session tonight. As Linda mentioned, I've been chairing a small group that's been taking an active interest in the Scott Base development from the Society's perspective. But one of our main objectives with that was really to make sure that Society members and the wider community knew about the development, had an opportunity for input, and knew what was going on. So this webinar is a fantastic opportunity, and I really like to thank the many people that have worked behind the scenes to make it happen. For tonight, what we'll have, I won't say too much, and then we'll have Simon and Hugh giving a tag team presentation. And at the end, they're happy to take questions. Now, the easiest way for you at home or in your workplace to participate is to sign into YouTube and ask your questions in the chat there. And then at the conclusion, we'll be able to ask those of Simon and Hugh. So it's not a verbal thing, but if you use the chat, we'll relay as many of the questions as we can. You'll appreciate that the project is work in progress and there are some things that are not pinned down yet. So if Simon and Hugh can't answer some things, it's just because it's work in progress. So we're really delighted that they're talking to us, and we're really interested to hear what they have to say. As Linda mentioned, they've got stunning experience. Simon, particularly from an Antarctica New Zealand perspective, with Scott Base experience, project management experience, and Scott Base project management experience. So couldn't be a better person to lead up the project for Antarctica New Zealand. And Hugh has As the design director for the project, he has done a range of innovative polar projects. Many, if you followed Antarctic news at all, you will have seen his project. So we're really excited for New Zealand and for the project that he's part of it, and looking forward to hearing from him. So feel free to add your questions in the chat while they're talking. We won't break them up during the presentation, but we will come back to the chat, the questions at the end. And we're hoping that the talk and the questions will be about an hour. So that's what you can expect for tonight. But without further ado, Simon Hugh.
Thank you, Tenzin, and thank you very much, Linda. That was a lovely introduction. We're really, we feel really honoured to present and be the first of your YouTube presentation. So congratulations on that, and I hope one day that the team down at Scott Base will be able to at least watch YouTube and perhaps even this one. So thank you very much. It's an honour to showcase the project that we've got. So I would, can everyone see that? So I'd just like to introduce Hugh. So Hugh joined our team in 2017. He teamed up with a company called JASMAX, and between JASMAX and Hugh Broughton Architects, they lead the architectural side of the project. So I started the Scott Base Redevelopment project in 2016 when we initiated the project for Antarctica New Zealand, and have been working on it ever since. So this was one of Hugh's many Antarctic projects, as Tenzin mentioned. So Hugh also still works closely with the British Antarctic Survey, the Australian Antarctic Division, the National Science Foundation, and the Spanish Antarctic Program. So we're really grateful to have someone with Hugh's experience in Antarctic architecture and construction as a key member of our team. And he also has a number of people within his practice who also have worked on a lot of the other projects that I mentioned, which also add experience and knowledge to the design team, which is very hard to find across the world. So it's a pleasure to work with Hugh and his team. So for those who haven't been fortunate enough to travel to Scott Base, it's 3,800 kilometres from Christchurch. Christchurch is one of 5 gateways around the world, and it usually takes about 5.5 hours on a US C-17, which is a large Air Force jet. But sometimes we also travel there on Hercules aircrafts, and the flight can be anywhere between 7 to 9 hours, and even longer if you end up back in Christchurch on what's called a boomerang flight. So Antarctica is on our southern flank, and New Zealand has been involved with Antarctica from the outset of the signing of the Antarctic Treaty. So we're a very proud member of the Antarctic Treaty. We have a proud reputation in environmental stewardship, high quality science, and conservation, and we also have economic interests there, where we have a lot of business that goes through Christchurch and New Zealand to support Antarctic stations such as McMurdo, South Pole, Murray-Zakali, Jangbogo, and many of the other countries that work around the Ross Sea region. Out of Christchurch, we have the US, the Italian, and the Korean program, so they all have offices within Christchurch. And we also facilitate the Chinese, French, and German program as the gateway. So they both use the Littleton Port and Christchurch Airport very regularly to get down to their various stations in the Ross Sea region. Antarctica New Zealand is the government agency responsible for carrying out New Zealand's activities in Antarctica and supporting world-leading science and environmental protection. Our vision is that Antarctica and the Southern Ocean are valued, protected, and understood. So Scott Base is located at Pram Point on Hutt Peninsula, which is on Ross Island in McMurdo Sound. So you can see it's at 77 degrees south and 166 degrees east. So it's the furthest southern point a vessel can travel to if they can get through the sea ice. We're very close to McMurdo Station, about 3 kilometres away, and we work very closely with the National Science Foundation and the US Antarctic Program and collaborate heavily on logistics particularly. We have a thing called a joint logistics pool, which is where we share assets such as vessels and aircraft to move people and cargo to and from the stations, but we do operate independent stations. Collaboration's a really important part of working in Antarctica, and we work closely with a lot of other national Antarctic programs, and that's really the only way that things work well down in Antarctica, particularly when for search and rescue events and so on, everyone bands together and helps each other out. So it's a very collaborative effort, especially for a lot of government agencies. So the new base is intended to be located at Pram Point. We did look at other places to position the base, but we did come back to Pram Point being the best location to position the new base, and that's for a range of reasons. So only 0.36% of Antarctica is snow-free, or sorry, called ice-free. So having an area that is that you can found buildings on solid ground, which isn't ice or an area that builds up in snow a lot, is obviously a very rare piece of land. So we also didn't want to push further afield and move our location to another area that was snow-free, that hadn't already been inhabited. So we're intending to continue our presence where we currently are. So the history of Scott Base. So forgive me for those in the society who know this well. I'll give a high-level overview. So Scott Base was first built in 1957, and the team was led by Sir Ed Hillary. So it was the primary purpose of it was to support the Commonwealth Trans-Antarctic Expedition, which is known as the TAE, and Scott Base was officially opened on the 20th of January 1957, which is the top middle photo there. It was also used to support a party of scientists participating in the International Geophysical Year, which is also called the IGY. Although it was only designed to last a few years, the value of Antarctic research was soon recognised, in a base rebuilding program then began in 1976 to replace the original base from 1957. Hugh and I are constantly impressed at the innovation that was used in designing and constructing the TAE hut, which is the building that you'll see on the right-hand side. It was designed and built in under a year. They completed the buildings in Wellington and showcased them to the public, so the public could go through them and have a look. And then they deconstructed it and moved it down on a vessel and tracted the materials onto site, as you can see with Sir Ed behind the wheel of the tractor there. So as I said, the second generation base, which you can see in the bottom left-hand photo there, was the construction of the second generation base, which went from 1976 through to the mid-1980s, and it was built over 12 stages, connected with Linkways in a similar fashion to the original TAE base. Linkways are something that makes Scott Base very unique, and even in comparison to a number of other, well, most other Antarctic stations, the Linkways are a popular feature of both the first, second, and proposed Scott Base. The TAE or IGY hut was the first hut built as part of the 1957 IGY expedition, in the Antarctic Heritage Trust conserved that, and it still remains on site, which is just on the right hand side. So in 2001 it was listed as a historic monument under the Antarctic Treaty. It contains material recordings New Zealand's involvement in Antarctica since 1957, such as the geomagnetic observations. So this is an aerial view of Scott Base. As you can see, there's a road that leads up towards 3 wind turbines, which you can see on the horizon, and that road leads off through to McMurdo. It's built, as I said, over 12 main buildings, and it's been built on over the last 20 years as the needs of the science community change. So the most recent building project that we did down there was some additions to the Hillary Field Centre, which is the large building on the right hand side, where we increased the size of the building and changed its function. It's like a small town in just under 7,000 square metres, so it has anything from wastewater treatment plants to a reverse osmosis plant, fire pumps, fire water storage, drinking water, vehicle workshops with 4 bays, light engineering workshops. It can house up to 86 people, and has various things such as libraries, gyms, and areas to do yoga and stretching and so on. So they're all very important places. There's also a number of science labs, so anything from wet labs to dry labs where electronic scientific equipment can be tested before it goes into the field, or analysis can be done on samples once they do come back from the field. Staging of gear and materials is really important as well. So you'll see a number of containers in the image, and a building we call the hangar, which doesn't actually house aircrafts, which is down on the left-hand side near the shoreline. So that's where a lot of waste processing and gear and spare parts is stored. So out the front of Scott Base is sea ice, and this doesn't break out every year, but it does break out. And at times we have an open ocean out the front of Scott Base, and if we're lucky enough, you do get to see whales popping up. It's also a colony of seals, which you can see out on the right-hand side, which was one of the reasons that the site was chosen in the first place, where seals were used to feed the dogs. So dogs are no longer housed down at the base and used, so they were removed a long time ago. So all being said, the base has served us well, but there are a number of issues that we are having to actively manage. So we would the preference is to design those out with passive controls and with a new design and a new base. So there's a handful of them on the screen here. So we do have inefficiency by having the base across multiple levels. So while it may be perceived as inconvenient, it can also cause issues when we're trying to move materials and things like food through the base. So from where it's stored through to the kitchen, it means people have to manually lift it for quite a long way. And we've also got a number of critical services which are under the floor and really hard to access. So if something goes wrong, it is really difficult to get to the problem and identify it and remediate it as quickly as possible. So within the new base, we will have easy to access services which you can see and address really quickly. It also, over time, as technology has evolved, the floor spaces have filled up, so they're at capacity, and this not only has issues with access, it also constrains anything else that we can put down there. So key equipment is old. The reverse osmosis plant, for example, is the same reverse osmosis plant that was put in the 1980s. So it does require a lot more maintenance, and it is a point of failure if we weren't to be able to make water from an old piece of plant. It's also housed in the same building as where our generators are. So there's risks around if the generators were to have an issue, such as catching on fire, then you also lose other critical life support systems. So we're looking to design those out. There's been a lot of development in the area of snow modelling. So the current base was designed and built over stages, as I mentioned earlier, without necessarily a holistic view of how snow could be managed across the site and what it meant to put a another building on in a certain area. So Hugh will come to some of the work that we've done on snow modelling, but at the moment this is an issue that we have to spend quite a lot of time and bulldozers and excavators to remove the snow each year. And this also increases our risk of damage to buildings, and we also use a lot of fossil fuel, obviously, with the machinery to remove it. So we're looking to reduce that. We don't think it's possible to eliminate snow drifting, but we do think we can reduce it a lot more. So the project has 5 objectives. First one is to maintain a continuous presence in the Ross dependency. Want to protect the Antarctic environment. Want to provide an environment that keeps people safe and healthy. We want to enable logistics to support high quality science, and we want to maintain New Zealand's credibility amongst Antarctic treaty nations. So a key theme there is around how much we value environmental stewardship. So you'll see that in a number of ways as Hugh gets into the design, but these project objectives are really important to guide the direction of the project and ensure we focus on the things that are important. So the project was initiated in 2014 as we reviewed the asset management requirements of the existing base. The first tranche of funding that we applied for and were successful was in 2017, and that was supported by an indicative business case. So we're funded through Treasury, and we follow what's called the Better Business Case process, where you have a number of business cases which apply for money at certain times, with the final business case being an implementation business case, which is what we're currently focusing on. So in 2017, we commenced what's called concept design, and we then progressed that into what's called preliminary design, and that informed a detailed business case that was submitted in December 2018. That was then supported by Cabinet, and we received the next tranche of funding, which was $18.5 million, which is the stage of the project that we're working in at the moment. So the deliverables from this stage, which we've termed stage 3, stage 4 and 5 being construction and closeout. So for stage 3, which we'll complete by May next year, is to complete the developed design, complete an implementation business case, carry out the comprehensive environmental evaluation and submit that, and engage with the construction industry and identify a main contractor. So when constructing a similar building in New Zealand, the construction costs are approximately 1/3 of what it is in Antarctica. So we call this the Antarctic factor. And someone said to me, this is a logistics project with some construction on the side, and it's not quite true. The construction is really important, but it does have a huge logistics component to it, and it is really challenging logistics, especially when we're having to involve things like icebreakers and large vessels to move large amounts of materials. We also need to move people. So this is done via aircrafts, such as I mentioned earlier. And this depends on how we go about building the building, whether it's done predominantly in New Zealand or down in Antarctica. So Antarctica New Zealand manage the logistics typically, particularly for moving people, but this is to carry out this project, as it says underneath the title on the slide. It's the largest project ever undertaken by Antarctica New Zealand. So this the type of logistics that we'll be using aren't normal. So is the base, the purpose of the project is to provide a safe and fit for purpose facility for Scott Base, and one that supports high quality science and enables protection of the Antarctic environment. So supporting science is critical to this project. So we have 2 main purposes of having a base in Antarctica. So one is for presence, and the second is for science. So New Zealand scientists are world leading, and scientists have been researching Antarctica since the days of the first explorers. So it's a key part of developing the brief for the new base, and we've been working extensively with the Antarctic science community across New Zealand and those in other countries that also use Scott Base to understand exactly what they require. It's really hard to define the future of science, though. So a lot of the spaces, as Hugh will get into, we look to ensure they're flexible enough to support science into the future. The warming world impacts Antarctica and the Southern Ocean, which in turn affects New Zealand and New Zealanders. Antarctica acts as an early warning system, which is why it's so important and why we believe we need to continue an active science program through Scott Base. Much of the science that's conducted through Scott Base also provides valuable guidance on policy and management, which then informs the way that we live. I mentioned the comprehensive environmental evaluation earlier. So this is a document that outlines a lot of detail about the design, the construction methodology, the demolition methodology, and the impacts that the project may have on the environment and how they will be controlled. So it's similar to an international resource consent that is submitted to the Ministry of Foreign Affairs for approval. We intend to submit the CEE in 2021, and then it goes up for international consultation. So this image is of some NIWA divers out the front of Scott Base who are going under to survey the seabed floor and put in transect lines. So this is one of the many monitoring measures that we put in before we even do anything on site in terms of construction. We also have a lot of monitoring stations around the site, so they're capturing baseline data, which is what we then evaluate the impact of the construction program against. So we do it in real time. We don't just wait till the end to see what the impacts were. We have a number of controls in place that we work with the contractor in, but first we need to have a really robust baseline data set. So this is the 3 wind turbines that we currently have down at Ross Island. So this is on a shared energy grid with McMurdo, and this is one of Antarctica New Zealand's contributions to the joint logistics pool and reduces the consumption of fossil fuels across both bases. So we're working really hard to reduce the amount of fossil fuel consumed in the new base, and testing as much of the design assumptions as possible, so we really do reduce the environmental footprint. It's really difficult to eliminate the using fossil fuels down in Scott Base, because we do have to have a high level of resilience because of the isolation and the harsh climate that exists down there. So to have a continuous means of power, particularly for heating and providing water, they are big energy draws. So we've investigated a lot of different options, such as photovoltaic, reusing waste heat from generators or water production, anaerobic digestion, a range to see what is possible down there. It's also a balance between having really complex systems and people that can maintain them without having a high degree of your beds used up by lots of technicians rather than scientists. So that's one thing that we're working really hard on. We're also trying to reduce our waste generation as much as possible. So that's not just in construction, but it's looking at how we manage inventory in the new base and what we use to store and send things north and south. and using standard systems. We're also looking to improve our biosecurity requirements and containment capability, so dedicated biosecurity facilities, and that's intra and intercontinental. We've been working with the New Zealand Green Building Council on a Green Star independent accreditation for both the design and the building once it's complete, so design and construction, and that drives a lot of sustainable practices in the design and build, which we're seeing is adding real benefit to both the design. It also drives environmental requirements around people's work and spaces that they live in, which we think is really important, given that some are down there for more than 13 months in 24-hour darkness. So culture is really important at Scott Base. For those of you that have been there, it leaves a lasting impression on you for life. So this is something that we want to maintain and enhance. It has a very egalitarian feel. Everyone gets put on dishes duty, and we believe that this is what makes Scott Base really special. So we have a strong desire to continue this, but we've also been working with iwi across the country to inform the design and the Antarctic Heritage Trust to continue some of the features that the existing base has. Like I said before, it's more than just a workplace. This is where people have to live. So it's very unique in the way that the design goes together, in that workplaces must be really specific, but we also need places that people can relax and enjoy themselves. So moving on to the design, we've partnered up with the companies that you'll see on the slide here to deliver the project. So WSP do our civil and structural engineering. Hugh, Broughton and Jasmax, as I mentioned earlier, lead our architectural team. Rawlinsons are our quantity surveyors and cost consultants. Stenson and Varming do our building services, so that's heating, electrical, wastewater, water production, fire, those sorts of things. And then the building intelligence group are leading our design, so design management. So just before I hand over to Hugh, I'll just provide an overview of the design process. So the design process is split between 4 different stages. So I mentioned earlier concept and preliminary design. So those were completed from 2017 to 2018 for the Scott Base Redevelopment project, and we're currently midway through developed design. So the final phase is called detailed design, and that's when you'll write in the detail of how the building goes together. So for that, we'll have the contractor on board, and we're in the final stages of the procurement of a main contractor. So for a project like this, we see it as being really important to have the contractor involved with how the buildings will go together while the design is still being finalised, so we can carry out any changes that may be required. So that's all for me for now. I'll hand over to you, Hugh.
Thanks, Si. And thanks for a fantastic introduction to the design process there. I'm just going to run through with everybody the design that we have prepared. But of course, before you prepare any design, it's essential to determine the constraints which help us to decide where we can place buildings and the approach to design generally. So bizarrely, for a building in the Antarctic, Scott Base presents an enormous number of constraints to the design process. One would imagine that if you were building in the Antarctic, you'd have a pretty free rein. But at Scott Base, there are a number of factors which determine not only where we place the buildings, but also the form that they take. There's a long history, as Si has mentioned, associated with Scott Base, and that manifests itself in particular in 2 particular areas. On the one hand, there's the historic hut of Sir Edmund Hillary's Trans-Antarctic expedition, and we want to make sure that any new buildings don't crowd that important historic asset. On the other hand, and crucially ongoing, the long-term science data, which is being collected by instruments quite close to the base. And that's also been a determinant on where we can put new buildings. Scott Base sits on the coast, so that in itself is a factor in determining where buildings can go. Mindful also of the potential for changes in sea level and of the impacts of things like tsunami and so on. That's also made an impact on where we can, how close we can place buildings to the coast. Scott Base suffers severe winds. The prevailing wind blows from the northeast, but the strongest winds blow across the ice shelf from the southwest. Those are the winds that actually pick up snow and ice off the ice shelf and create the big drifts around the base. So placement of the buildings as close to perpendicular to that wind and then elevated will help to limit the amount of snowdrift and therefore the amount of management that's needed. The base is located on a sloping site. There's at least a 20 to 30 meter level change across the site of where the existing buildings are. And that in itself has a big impact on the way that you design buildings and locate one next to another. So I've already talked about McMurdo Station, and the road that leads to McMurdo passes right by Scott Base on its way out to the airfields. And the position of that road, again, has an impact on where buildings can be located, even though we may, in the long term, have plans for some reorganisation of that road system. And then, of course, there's the existing buildings themselves. And when redeveloping the new base, the potential to keep as many of those existing buildings in operation to facilitate the construction is an important factor and has some impact on our design process. So with all those factors in mind, we started the design process looking at a series of different options. And here you can see some of the sketches that we prepared along the way as we started to get to grips with the brief provided by Antarctica New Zealand and through our engagement with stakeholders, both within the organisation and externally. Alongside preparing sketches and thinking about the areas and the different spaces that we needed, we also went out into the field. We went to visit a whole series of different science installations around New Zealand to get to grips with the kind of science that would be conducted at Scott Base and to ensure not only that current science programs could be accommodated, but also that there was sufficient flexibility to support science which would be taking place at Scott Base over the next 50 years. And as you can imagine, that is quite a challenge. It's hard enough to design around what we know, but to design for 50 years into the future is really quite something. And the key to this really is to provide spaces which we like to call as being loose fit, spaces which can be relatively easily reconfigured over the life of the base. These are some of the examples of places that we went to visit and that have been facilitated by scientists within New Zealand. A fascinating visit to the NIWA Marine Lab at Wellington to see how they manage the use of seawater to support their facilities there. We also went to Victoria University to the new building supporting biological sciences, amongst many other installations that we've been to visit to support the design process. The Scott Base has science facilities within it, but it also supports fantastic science out in the field, some of which is really quite far away from the existing facility. That science is supported by traverse activities using vehicles to cross over the Ross Ice Shelf, also by helicopter operations. And the new Scott Base will be different from the current base in that the helicopter operations will be brought right next to the existing buildings. Currently, the helicopter operations operate out of a hangar at McMurdo Station, although there are pads at Scott Base itself. So to facilitate our understanding of how that helicopter hangar would best be designed, we went on a visit, for example, here to Garden City Helicopters in Christchurch to see what was needed in terms of hangaring, but also in terms of maintenance of helicopters and storage of equipment and parts. So all these visits have had a crucial impact on the development of the design. As well as making visits, of course, it's really important to talk to people who work at Scott Base, people who visited Scott Base, and the many stakeholders, many from around the world, who have a part to play in the operation, both in terms of health and safety, but also in terms of science output. And this slide shows SCI in action when we went to Scott Base in February last year And we got together a group of people on base to talk to them about what are the key constituents that make for a good selection of recreational spaces to support people's well-being when living so far from home. And it's a really fascinating event, just asking people what were their key features they were looking for, what are the things that they find difficult about the current base, what are the things they enjoy about the current base, what would they like to see repeated, and what would they like to see changed. And we collected together all that information, and that again informed the approach that we've taken in the design of the new buildings. I find particularly interesting on the Scott Base project the potential for integrating the culture of New Zealand into the design of the new buildings. That has multifacets to it. On the one hand, there's the integration of New Zealand's Maori culture into the building. To help us to get to grips with that, the whole team went on an overnight stay at the marae in Christchurch, and here you can see the design team fresh-faced in the morning after enjoying some really fascinating conversations about what constitutes the culture of the base and how that can be emphasized, embellished, and captured within the designs of new buildings. Of course, the culture of Scott Base is not only about the culture of New Zealand, it's about the culture of expeditionary endeavour, which really characterises this whole part of the Antarctic. This is the historic heartland of Antarctic expeditionary endeavour, stretching right back to, for example, Scott's expedition in the Discovery of 1901 and Shackleton's Nimrod expedition of 1907 to 1909, and then subsequently Scott's expedition to when he reached the South Pole but sadly did not return. So we've been working very closely with the New Zealand Antarctic Heritage Trust to understand the significance of that history, of the place of Scott Base in the history of Antarctic architecture and buildings, and how that history can be captured and brought to life within the new base. Key to that process, I think, is understanding the origins of Scott Base itself. And as Si mentioned, in 2017, the New Zealand Antarctic Heritage Trust completed the restoration of Hut A, the first building constructed as part of Sir Ed's Scott Base in 1957. And I think you can just look at these photographs on the screen at the moment and you can just recognize why he was such a great expeditioner. This building not only withstands the elements, but actually it provides a home from home for the scientists and field operators who worked with Sir Ed back in 1957, creating a space which is comfortable, but at the same time fit for purpose, engages with its environment, has a feel of New Zealand, but is very much of its place within Antarctica. And I found particularly moving going into this building and thinking about the ways that we could capture again some of that spirit of expeditionary endeavour that we see in Sir Ed's building within the new designs. So that's a lot of armoury as a designer to start the process. So here's the existing Scott Base, as Si mentioned, 12 buildings on multiple levels, facing a number of challenges. And with all that information packed away in the backs of our minds and going through a series of concepts, here finally is our reveal of the design of the new Scott Base. So resolving those 12 buildings to down to just 4. And what they comprise is a building at the top. We call them after these letters, A, B, C, and D. Building A is the accommodation building. It's on 2 stories, like all of the other buildings, with the sleeping accommodation, dining spaces, some recreation spaces on the upper levels, and then more functional spaces, things like the laundry, medical facilities, locker rooms, food storage, and so on the lower level. The buildings step down the sloping site of Pram Point. So the lower level of building A connects into the upper level of building B, and then the lower level of building B connects into the upper level of building C. Building B is the Science and Operations Centre for Scott Base. So it contains laboratories, science staging areas, operations facilities, collaborative science workspaces, and the management team's operation space. And building C is the engineering and storage heart of the building. So it's got things like a 6-lane vehicle workshop. There's also carpentry workshops, plumbers workshops. That's where you'll find all the water treatment plant, much of the air handling equipment, generators, and so on, as well as storage. Storage not only to support the operation of the base, but also storage to facilitate deep field science operations. And the benefit of this connection with links is that you can wheel your equipment from those field stores at the same level through to the event staging within Building B. And then the fourth building, which isn't connected to the other three, is Building D, which is the helicopter hangar, which also contains a couple of spaces for atmospheric physics, for the launch of balloon radiosondes, and also for the operation of drones, which is seen to be an exciting development in the science field in Antarctica. The building is around 10,000 square meters, so close up it does look reasonably big, but I think then you step back a little and look at it in the context of Pram Point, and it takes on a relatively modest appearance. Angled on its roof to reduce the amount of snow management, because the wind will just flow over the top, flow underneath, and reduce snow drift potential around the buildings. But also in a grey metallic sort of finish potentially to help it again just blend into its landscape, really drawing upon that environmental driver to minimize impact within the Antarctic environment. In terms of the design of the form of the buildings, the snow modelling process has been a key determinant. So we knew that the strong winds come from the southwest. We knew that the buildings would need to be elevated so that the wind would flow underneath, and we could utilize that wind to minimize the risk of snow drifting round and about. But there were still many questions that were left open, such as the relationship of one building to another, the distance apart buildings could be spaced, or even the shape of the buildings themselves. And to help find answers to these, we went to the laboratories of a company called RWDI, who are based in Guelph, outside Toronto in Canada, who run a water flume where they can simulate the way that snow moves around buildings and the way that it drifts. So what they do is they have this big tank of water, and then they have a brass pipe which introduces small particles of sand, and then they start a flow running through that water tank. And then the sand is dropped in, simulating the way that snow is carried through the air and then can deposit around buildings. And to simulate the particular environment of Scott Base, they dropped the zone in which the sand was introduced to quite a low level to simulate the way that snow blows across the ice shelf towards Scott Base. To calibrate the drifting, we made a model of the existing Scott Base, and then analyze that against photographs and drawing upon the experience of people who've lived and worked at the base over long periods to make sure that the drifting we were seeing in the model was similar to the drifting that was being witnessed on base. And then the fun started. We put models of the proposals into the flume and saw how the snow drifted around, and then started making variations to the model to come up with the optimum arrangement. And it really was a fantastic iterative process over about 3 days as we tried different permutations, going right down to the detail of how ramps connect into the buildings, as well as looking at the shapes of the links between the buildings and the shapes of the buildings themselves. And that really did help to literally sculpt the solution that we now find ourselves with. Of course, it's not all about design architecturally or of shapes or siting. Building services are a key design driver for this project. And that's because when you live and work in Antarctica, you really are reliant on the resilience and robustness of those building services to support your very existence, to maintain heating systems, to maintain your water production, to ensure that waste is disposed of sensibly and responsibly, and to ensure that fire safety is absolutely to the highest possible levels. So working with Steenson Varming, we've come up with a solution to that, which has just helped us to create a solution where fuel consumption can be reduced by making the most of passive energy sources, whether that's wind or solar energy, that we've come up with a clear system logic whereby all the services are easily accessible and easily maintained, reducing effort to keep the base operational. Resilience is absolutely key. So there are generators in 2 different buildings. We've got power from the wind farm coming into the building as well. And the benefit of having those power systems in different buildings is if ever there is a system failure in one, then you can rely on the power source in another. We've also looked at optimizing services for winterization, so that, for example, when the population of the base might drop from 100 in the summer down to around 15 or 20 in the winter, it's possible to close down a number of those bedrooms or spaces which aren't being used, reducing their temperature down to above freezing, around 5 degrees Celsius, but nonetheless to require much less energy to keep them operational. So some of the different measures that we've got within the buildings include measures to reduce water usage, such as vacuum drainage and a mist fire suppression system, which starves fires of oxygen rather than dousing them with water. We've got combined heat and power generators, allowing us to capture heat off the generators themselves to use that as part of the heating system within the buildings. We're utilizing electrical energy to the maximum, drawing upon the power of the wind farm. So much of the heating, much of the time, is provided by electric boilers rather than boilers that are driven by AN8 fuel. We've also got anaerobic waste treatment, which means that the amount of waste that needs to be returned to New Zealand will be minimized even by comparison to the existing base. And overall, the intention with this whole services strategy is to provide an environment which is really comfortable and supportive. Our engineers have their origins from Denmark, so they like to call it as a hugelug type environment. Although, of course, this is a building in New Zealand, so we like to think that we're encouraging Manakitikahitanga. So this is a view of the exterior of the building on approach. You can see that there are ramps leading into building C on the left-hand side and to building B in the middle. Those ramps are to facilitate the delivery of cargo. So the building on the left-hand side, building C, that will be cargo that's coming in from New Zealand or returning to New Zealand. Whereas the building in the middle, that's the science building. So that would be events from the deep field coming back into the building or going back out into the field. And on the right-hand side, that's the main accommodation building. So it has a stepped access because that's primarily for pedestrians coming in and out of their accommodation. This is the main entrance. As you can see, the buildings have a monopitch. They've got lots of curved corners to them, and they're elevated above the ground. And that is all in relation to that wind and snow modelling to ensure that the wind flows over and under to minimize the amount of snowdrift round and about, and therefore the amount of effort needed to manage snow. The primary entrance has quite a bit of glazing to it, and that's really an important feature to generate a sense of welcome, which is going to be a key characteristic of the design of the new Scott Base. So on the upper level, that's the main dining space and the bar, looking out over people coming to visit Scott Base for the first time or returning people as they come back in from their work in the field. People have asked about the colours. Colour at Scott Base in the new proposal is still under review, although we're drawing upon a strong attachment to the cucumber green in these current illustrations. Internally, the idea is to create an environment which is supportive of people's well-being as a community, but also supportive of people's well-being as individuals. We're also very keen to emphasise the connection to New Zealand, not only in terms of the general design, but also in the selection of materials. So this, for example, is an early proposal for the dining space on the upper level of Building A, with the big glass window framing views of Mount Erebus and Mount Terror looking across the pressure ridges where the Ross Ice Shelf joins on to Ross Island. framing that awesome view and really linking people to the environment in which they're living, but also cocooning them with this timber ceiling potentially made of Southland Beach, making a strong connection to the New Zealand origins of the space, and also making people feel warm and looked after within the new building. Off to the right will be the bar, so there'll be big screens which open up to allow interconnectivity on some occasions and then separation on others. And it's really through a lot of discussion with people who live and work at Scott Base, both now and in the past, that we have arrived at the design solutions that we're showing this evening. In terms of the sleeping accommodation, there are really two types. There are single rooms for all the longer term residents, single rooms with views out onto the landscape. The rooms are pretty compact. They're around 2 meters wide by around 3.5 meters long, with plenty of storage and the option of either an easy chair or a desk at which to work, shelving, and blackout blinds, and with a towel rail just to allow a little bit of control of the environment within the space that is your own. Lots of pin boards for putting up pictures and for putting in books and so on. Many of the visitors to Scott Base come for much shorter periods of time, however, maybe passing through as they head out into the fields on science events, or even from other national Antarctic programs utilising the air link back to New Zealand or through McMurdo. And so for them, we've created twin rooms. These twin rooms actually look into a double height space within the heart of Building A, so they get natural light and allow for just a densification of the sleeping accommodation just for those people who are there just for a few days. Links, as Si has mentioned, are a really important feature of Scott Base, stretching right back to Sir Ed's first buildings of 1957. And we've maintained that theme with the new design, with all 3 buildings connected by links. And this is a view just within the links. They're around 3 meters wide, so that they allow people to walk in both directions, for cargo to be moved between one building and another. And then at the center, they have these panoramic windows for people to enjoy the views in summer out onto the icescapes, or in winter of the spectacular auroral displays which take place around Scott Base. I think one of the things that we've learnt from working in a number of different Antarctic bases is not only the requirement to provide recreational spaces which support people's well-being at a number of different levels, and at the new Scott Base there will be plenty, ranging from things like a digital lounge to a movie room, a hobby space, a library, a bar, a gym, a fitness suite. Those spaces are important, but it's actually the incidental conversations that you have along the way which are so crucial to the success of the base. That time when you're walking across the link as a scientist and you meet someone from the operations team who's just able to help you to sort out that piece of equipment or facilitate some particular move that you need taking place. Or maybe it might be an operations person bumping into someone from the engineering side, again, being able to draw upon their experience and knowledge of a situation to solve your own particular problem at a particular moment. So making these linkways wide is also important for that kind of incidental exchange and collaboration, which is such a key feature of the base and which will really be a key ingredient of its success. As I mentioned earlier, flexibility really is going to be a key feature of the new building. And that's because it needs to support Antarctic science for the next 50 years. Key to that will be the event staging area on the lower level of Building B, which is designed as a big open plan space where people can get their equipment ready before heading out into the field. In the center of the space, they'll be able to have cages to put their various pieces of equipment, clothing, tents, and so on. And then off to the side, there are drier spaces for calibrating equipment, charging up electronics, and so on. And then upstairs within Building B, there's a large collaborative workspace where scientists can write up their trips, go onto the internet to research any aspect which is needed to support their own work. There are also laboratories. You can see those behind the glass screens on the right-hand side here. And this whole collaborative workspace is lit from above by roof lights, bringing natural light right into the hearts of the buildings. And you'll see this recurring theme again, of timber ceilings, potentially Southland Beach, being brought into these more public spaces within the building to give that strong cultural reference back to New Zealand, but also a sense of warmth within this cold, icy environment. One of the things I always find fascinating about Scott Base is that it has so many different activities that it needs to support. At the one hand, we're talking about sleeping accommodation, libraries and digital lounges. On the other hand, we're talking about laboratories to support cutting edge polar science. And then on the other level, it's an almost industrial type building with vehicle workshops to support those science events going out into the deep field. And here you can see an early sketch of the vehicle workshop, which would have lifting beams within it to help remove the engine blocks on some really big pieces of equipment, whether those are Caterpillar D6s or the Piston Bully 300 Polar, the Haglunds or the Toyotas, which are all necessary to support the activities in and around the base. For people's well-being, we've also included big windows from the gym and also from the trades office looking into that workshop. And the reason we do that is because in the depths of winter, when the crew is down to around 15 or 20 people, having good sight between spaces is really an important way of ensuring people's health and safety. So when the mechanics are working down in this space, someone in the workshops can go, yep, I see you, you're safe, we're all together, we're in this together. And I think that's that idea of collaboration is not only important for fostering new ideas, it's also a really key ingredient to ensuring health and safety of people working in such an extreme environment. So all these ideas are all coming together at the moment. As Si mentioned, we're in the develop design stage, really heading towards that finalization of the design to help a contractor come on board with the project. These are some views just of the outside of the building from the sea ice, looking back, seeing the building just sitting comfortably against the sides of Crater Hill with the TAE hut in the foreground, a building which supports science activity in the summer, but also supports the winter crew who maintain Scott Base through the winter. So hopefully that's given an overview of the architectural design. I know, Si, you're just going to give us a bit of a view on some of the engineering features now. So thanks.
Thanks, Hugh. So the civil design is really important and very unique. So the base is founded on permafrost. There's what's called an active layer, which sits at 0.5 metre or 500 millimetres below the surface. So that's an area of basalt and scoria that freezes and thaws every year. So the foundation solution that the buildings sit on is quite complex, and we've carried out a number of site investigations, such as coring the permafrost with a drill rig down to 10 metres to understand the material below the buildings. We've done ground penetrating radars, LiDAR surveys, and a number of other investigations. This image is not reflective of the colorings of the base. It's a technical image which talks about cut and fill volumes. So cut is where you have to excavate material, and fill is where you need to fill it in. So a key component to that is the levels that the buildings sit at. So it's quite a complex situation. We're also looking at deconflicting pedestrian and vehicles across the site as much as possible. So we do have a lot of heavy plant and machinery, and we do have a lot of people walking around. So that does cause risk to namely to people. So we're trying to deconflict those activities as much as possible by having safe vehicle routes that pedestrians don't use. So the structure, we did investigate looking to use timber. So there's a product called Accoya, but there were a number of issues with it, such as humidity, where you would get shrinkage coming from temperate climates down to Antarctica. We've got some material down there that we're testing at the moment, but the structure is proposed to be steel. So it's on a regular, repeatable grid at 6 meters, which helps with speed of construction and ease. So you have a lot of similar components, which also ensure that the cost is as reasonable as possible. We're not looking at a whole lot of bespoke design for certain areas. It's also a critical component for life safety. So because of the remote nature and very cold environment, the building is designed to what's called an IL4, or an importance level 4 building, which is similar to a lot of other structures that are important for people to use in the event of a natural disaster. So construction, we're in the process of confirming the construction methodology, or how the buildings will be put together and where they will be put together. So we've got a number of scenarios, and the scenario that you can see in front of us would be what we would term a partial prefabrication. So where we would use as many prefabricated components as possible. So that would be such things as foundation blocks or piles, structural steel. They would come down on flat racks or in containers and then be put together on site. So there may also be bedroom modules, as you can see the crane is lifting and placing in activity number 6, and then the additional structure and cladding would be wrapped around it. So this would require a high number of tradespeople on site, and combined with a constrained period where you can actually do these sorts of activities outside through that summer period. So it's usually from November through till the end of February. So it's a very short window in comparison to building in New Zealand. So at the other end of the spectrum, we're also looking at options to move large modules or whole buildings. So this is done a lot in the for industrial projects in the Northern Hemisphere, where you use a roll-on, roll-off method. And this has a number of benefits around quality and speed of construction, but it does have a different logistics component to it as well. So once we've confirmed that, we'll share that with the public. So this is our last slide. We encourage you to keep in touch. There's a website just in the bottom right-hand corner where we update regularly and have the latest news. So do head there and keep connected. We're now happy to take any questions, Tamsin.
Fascinating, and it's almost bedazzling the kind of level of detail that and thinking that's going into what you guys are doing. So thank you very much. We do have a number of really interesting questions. The first one, which I think is on top of everybody's minds at the moment, was around COVID and how that affects the logistics, and kind of thinking about on two fronts. There were a couple of different questions. Is there any opportunity to kind of accelerate things this year when normal business might not be happening? And the second one, really long term, through the construction period, the talk is that things will have a big impact. So what's your thinking on that longer term question?
Yeah, it's a great question. So in the short term, COVID has had minimal impact. We're in the design phase. So Hugh, myself, and the team have got very familiar with working on Zoom. So we've had hours and hours of Zoom, and we had a series of workshops over 4 weeks where we engaged with a lot of the science community and users. So that's really that's the short term impact, and so I would say it's minimal. We, like everyone, we're uncertain of sort of the next 2 years, I suppose, of COVID, and for this project, we're quite well placed because a lot of the work would need to happen in New Zealand before we start work on site. So we do have time to prepare for any site works. It is obviously to have COVID-19 in Antarctica would be an absolute disaster. So there's a lot of controls that are being considered to put in place to stop the transfer of that. So we are constrained by budget. So like I said earlier, we're funded for stage 3, so with the $18.5 million. So that is more of a constraint for us at the moment compared to COVID-19. But in terms of design, we're making really good progress. We're close to having the contractor on board. So there's great opportunity to get into things sooner rather than later and get the work happening in New Zealand.
I think maybe it's also worth mentioning, Si, that even within the design, we're actually at probably a good moment in that respect, that we can take stock of what would be good measures to introduce just to maintain health and safety at the base if ever there were any kind of infection. So some of the things we have got is we have a small group of accessible bedrooms, which can be isolated with their own ventilation system. So if ever it was needed because of some kind of infection, to set people apart for a short period from the community. A lot of the doors are on things like called electromagnetic retainers, which keeps them open, but then allows them to close in case of fire. So you don't need to touch things like door handles and so on. Most of the toilets have got their own wash hand basins within. Just there are a number of different measures along the way that we're taking stock of at the moment to try and minimize risk of infection. And I really think that's going to be a key consideration in the sort of detailed design that we're taking place at Scott Base at the moment.
Great. We also had somebody asking, obviously very aware of the McMurdo rebuild that's kind of kicking off as well, and how that might affect the plans for Scott Base, either positively or negatively.
Yeah, so like I said earlier, we work really closely with the National Science Foundation. So we intend to continue that through the delivery of both projects. So for those that aren't aware, McMurdo Station's also going through a redevelopment, which is called the AIMS project, so the Antarctic Modernisation for Science. So we will look to share a lot of assets, such as resources for offloading. So the New Zealand Defence Force do support the offload at the moment, and we intend to continue that. But at the same time, both projects have really specific deliverables. Plus, they work off different building codes and different materials, for example. So getting down to the level of perhaps sharing sheets of plywood or power tools doesn't work, because they operate obviously on have different plugs and different power requirements. But where we can collaborate is sharing things like seats on aircrafts, resource for offloading large amounts of equipment, or perhaps half a vessel or something like that, rather than sending 2 half-full vessels.
I think there's an important message though, that and the US New Zealand relationship is a really classic and excellent example of the levels of collaboration which take place in the Antarctic, and I always think it's particularly special in that respect, and it sort of works right the way through the programs. And so, for example, I have a really great relationship with Rick Peterson, the architect who's been working on the McMurdo project. We exchange ideas, and they may not be ideas related to building code, but they might be ideas to do with people's well-being and how you support that within the Antarctic environment. Our services engineers are doing the same in terms of services systems. And I really think that will be to the advantage of both projects, that level of collaboration. And it's a sort of magical and special feature, I think, of working in the Antarctic.
Cool.
Yeah.
Another slightly curly one for you. Somebody is letting us know that there's a base called Princess Elizabeth Base that is actually zero emission, and they'd love to know, is this feasible for Scott Base? And even if not, how might that influence Scott Base? And this is a question from Switzerland.
Could I maybe start with that one, Si?
Yeah.
So, we're big fans of the work that's been done at Princess Elizabeth, and its achievements are really fantastic in terms of achieving zero carbon status. It's a slightly different scenario to the Scott Base scenario, because Princess Elizabeth is really a summer-only station, so much more able to rely on wind and solar power. They do have, I understand, a generator in case there is an emergency. At Scott Base, it's a winter operation as well as a summer operation. So obviously there's no potential for solar power in the middle of winter, although we're now really looking hard at the technology related to battery storage and the potential for storing energy that's generated in the summer and using it in the winter. Obviously at Scott Base already there's significant reliance on wind energy. We're putting into place loads and loads of other measures, whether it's reduced water usage, high levels of insulation, thermally responsive glazing, at multiple levels through the design. We're looking at reducing the environmental footprint and the energy take up in the building. And seeing projects like Princess Elizabeth and aspiring to those targets is certainly a big ambition of the Scott Base project. But I think it's important also to recognise, above all, we need to ensure people's health and safety when working in this extreme environment. And in the middle of winter, you do not want to be losing heat and power. So that's got to be our number one consideration. And really in those objectives, it sits there very squarely at number one, ensuring the health and safety of the people working in the Antarctic.
Oh. You touched on the kind of intense logistics, Simon, and there's a good question that relates to that. How are you thinking about removing the existing base? Will that be staged, and how will that interrupt what's happening on the base?
So the short answer is to build a new base, there will be disruption. And given that we are using the existing site, so it's just about managing the extent of the disruption as best as possible and continuing to support high quality science. So in terms of the demolition, that can be done in a number of ways as well, and it depends on how we build the new buildings. So if we were to move large modules, then you may be able to move the, large modules of the existing base back in whole pieces and then deconstruct them when you get back to New Zealand. So that reduces the risk of things like polystyrene beads and the cladding escaping into the environment. You can also control that in a number of other ways. So that's one way. The other more traditional way is to deconstruct and containerize and send back to New Zealand. But logistics is a constant balance, so we wouldn't want to send empty containers down to fill up with demolition waste. Ideally, we would balance that out with sending materials down and backfilling them as well. So like most things, nothing's that straightforward, and it requires lots of thinking, and then overlaying the logistics with availability of vessels and particularly icebreakers. So the other way that McMurdo have recently demolished some of their buildings is using a large shredder. So it crushes virtually everything, and then they sort it out when they get back to New Zealand. So they crush and fill containers with a lot of unseparated waste. But we would, I think it goes without saying, we would look to recycle as much as possible. And that's not just in raw materials. We may repurpose some of the structure for education or museums, or if there's a interest.
Cool. Couple of kind of quasi-technical questions. One is somebody noting their experience from 50 years ago, and mine more recently than that confirms it. The little electric shocks that you get when you're walking around Scott Base due to the extremely low humidity. Are they going to be a kind of cultural feature of the new base, or is that going to be eliminated?
No. I think there are many attributes of the current building which would be great to repeat, but those little electric shocks might be one we try to get rid of. The best way to do that is in humidifying the space inside, because it's the dryness of the air which is the main cause of that sort of static that you get. So humidification will be a key part of the mechanical design for the buildings. There's also a kind of whole earthing system related to things like building envelope and so on, which will be integrated into the design. So if it was something that you enjoyed in the past, I'm afraid it won't be something you enjoy in the future.
That's awesome. I'm aware that we're kind of, we've been generous with our time allocation. So if you're happy to take two more, then I'll feed you a couple more.
That's fine.
Great.
Yeah. What sort of limits do you have on prefab component size and weight and the kind of ability to unload at the base?
I'd like to say very few, but it comes down to there's limits for, so we can move 100,000 pounds in a container and truck. So if that's a 20 or 40 foot container, so that constrains a containerized method of delivery. But when we start to look at moving large modules, then we're looking at around about 500 to 700 tons that you can move through modular wheeled platforms or ship cranes. So there's a number of constraints that we work within, and then we look at other options for doing other things. So there's not a standard constraint, aside from when we're moving 20 and 40 foot containers, and even then you, so say for plant, for example, you would break it down into components that you could then get across the Bailey Bridge that is on the ice pier.
Cool.
So hopefully that answers your questions, but if you were asking me something specific to move, I could give you a specific answer.
But prefabrication is really a key ingredient of the design, and it's both to speed up the construction process, but it's also to maximize the quality of the building at the end. If you can make things in a factory in New Zealand, you can check it and double check it. And obviously it's much better to be doing that in a temperate environment than to be doing that in the Antarctic. So wherever possible, things will be prefabricated, and then it's just a question of the scale of the final module, which is we're just getting to grips with at the moment. But prefabrication is really the #1 mantra for the process.
Yeah.
Cool. And the final question is not quite personal, but shout out to my friend Alyssa, who I shared a bunk room with at Scott Base, and she's asking that you mentioned having multiple levels with the current base was a bit of a safety issue for moving things around, but obviously you've got the tiered structure. So does it have lifts, or how's that working?
Yeah, so within each building, on the line of those links, there's a lift sized not only for carrying people if necessary, but mostly for moving goods and so on. And then there's also staircases on those primary access routes as well. So the movement of goods around will just be a whole lot easier. Yeah, but there's 3 hoists, 1 for each building.
Brilliant. So there are a number of other questions, but we could probably keep on going till 9 o'clock if we went through all of them. So I think we'll release people. Si to probably enjoy his evening, and Hugh to start his day job. Who's joining us from the UK. Thank you so much for your time. It's been really enjoyable and informative. I'd like to thank the technical crew behind the scenes, Sam at Antarctica New Zealand, Nicholas O'Flaherty, who was particularly instrumental from the Society's perspective in setting it up, and Stefan and Georgia, who've been our technical people. Things get run pretty smoothly, but we'll look forward to feedback on that, and definitely encourage everybody to keep an eye on the Scott Base Redevelopment website to kind of keep abreast of news. And I'll just pass over to Linda to finish up for today.
Okay, thank you, Tamsin. Well, you haven't disappointed. Not that I expected you to. I'd like to thank you both, Simon and Hugh, for such a detailed and diverse series of presentations that gave us both the backgrounding and also the resultant future-focused proposed design. Speaking perhaps personally, but also hopefully on behalf of others who have joined us this evening, being strong in terms of sustainability, it's something that is at the heart of everything I've tried to do in 20 years of consulting and so on, and now as an associate professor. I'm really glad to hear that the New Zealand Green Building Council Green Star approach is part of this, and also that you are embedding the cultural needs, the scientific needs, and the logistical needs of both the Scott Base personnel, but also the whole New Zealand science program personnel. Having an architectural and construction project management background, and having been to the ice twice, last time was 7 years ago, and I was part of the volunteer painting team on Scott Base. I've actually really found this to be an insightful, technical, and resilient resultant development design to date. So I'd like to thank you both from a professional point of view, but also from the Antarctic Society's point of view. And again, to thank you for what you have put together in terms of that particular presentation. I'd also, as a final message, if I may, just remind people about the Antarctic Society website also, being antarcticsociety.org.nz, if you wish to join us as a member. But again, Hugh, all the best, and also Simon, fantastic, and also to echo what Tamsin has just said about the people who have managed to bring this together as well in the back rooms. So thank you guys, fantastic. Good night.
Good night.
Thanks, Linda. Yeah, I see there's a number of questions, so we'll get those through and hope to update you again when we've got some more news. So